Hello and welcome to Imagination at the AI Hardware and Edge AI Summit in California. I am joined here by Kristof Beets, our Vice President of Technology Insights. Earlier this week, we launched the Imagination DXS GPU, and Kristof is here just to tell us a little bit more about it. So, Kristof, IMG DXS is a new GPU for the automotive market. Can you just tell us a little bit about what Imagination does in the automotive market?
Absolutely. Imagination Technologies is an IP provider, so providing a main focus on GPU solutions. And the automotive is a key target there for us. So delivering solutions that meet the requirements of the automotive market. So focus on functional safety, which is increasingly important for self-driving vehicles, but also long-term support, very critical for our partners in the automotive segment.
Whereabouts in a car can our GPU IP be found?
Our car solutions have been found in all the parts that have had displays traditionally. So that started off in vehicle entertainment, so the center console, all the controls. But then increasingly, as the dashboards became more and more digital and screen-oriented, they've also been fully enabled by our GPUs. The new trend, however, is that all these different processing modules are centralizing. So we're getting a much larger GPU responsible for driving all the screens, but also a lot of the ADAS functionality, so driver monitoring, as well as surround view assistance. So really anything with a display, and increasingly a key part in compute as well.
So Imagination is the leading provider of GPU IP into automotive, and we have a number of customers in this market. What have they been asking for in our next GPU?
The key focus of our partners in the automotive market has really been around functional safety. And this is ASIL B level safety. And the problem, as always, is how to achieve that safety certification while keeping the cost and the overhead as low as possible. The traditional approaches to functional safety were really to duplicate work. And there were two methods of doing that. So one was a dual lockstep. So effectively two processors, you run the workload on processor A and B, and you would be constantly checking. But that means you're spending twice the silicon area. The other option was to have a single GPU processor and just run the workload twice. But now you've halved your performance. And for a lot of our customers, that was just not acceptable. So we've been working really hard for fully integrating testing mechanisms deeply into our GPU. So all the different pipelines within our design now have little self-testing units within them. And we actually bundle them up in safety pairs. And the key clever thing is then really to look for the idle cycles. GPUs are enormously parallel, and you're never using all the resources, all the processing units at the same time. So when we spot idle cycles, we insert the test patterns, and the hardware will be continuously self-testing. And that means we effectively do not lose any performance because we're using the slack that is within the hardware itself. But it does give us enormously high coverage to meet the ASIL B requirements. So very efficient, very cost effective, and very high performant for our customers. And that was really critical.
Amazing. So we're saving performance on safety, but IMG DXS also adds extra performance elsewhere.
Absolutely. So this is our D series, so DXS. Our previous offering in the automotive market was the B series. So you get all the architectural improvements that we've been doing since, so the C generation, as well as the D series improvements. And we're really seeing a 20% efficiency boost, just purely architecturally from all those improvements, like our pipeline data masters, as well as our dual rate texturing capabilities. But also in pure arithmetic performance, we've had a significant boost, actually 50% more than our previous generation. So more processing units, a larger capable processing unit, but we've also added in the benefit of dual rate FP16. So again, for compute, we're seeing a 3 times increase in number crunching capabilities. But of course, that's not all. The software angle is very critical for us as well. And this is where we are introducing our new compute libraries. So not just the new hardware, but also significant step up on the software story, building on open source frameworks, but then the lower levels, the foundational libraries such as BLAS and FFT and neural network libraries are fully tuned and optimized for our new hardware. And that can deliver us 2 to 4 times extra performance versus the traditional open source code that you find out there.
So which open frameworks is IMG DXS and the compute software working with?
Imagination is always very focused on open source and kind of standards that are driven by multiple companies, because you don't want a lot of fragmentation. So creating our own solutions doesn't really make sense. So we've been a key part of the UXL Foundation, which is building a lot of those higher level stacks, and that enables us to run a lot of content and take advantage of those frameworks, but also the fact that they're universal in the market. So it's much easier for developers and customers to build on top of that.
Mm-hmm. And then when you take that compute software and you add it to the improvements made to the hardware, you get a 10 times performance uplift in compute performance, I understand.
As always, it will depend on the specific workloads and content. But as I mentioned, we have the base hardware improvements. So the bigger 50% larger GPU. On top of that, the dual rate FP16, so that's a factor of 2. And then the compute efficiency from the software optimizations is again a factor of 2 to 4 times. That means if you add up all those numbers, you're somewhere between 6 times and 10 times faster. And that variability really comes from the kind of algorithms and processing. Of course, if you have very bandwidth limited workloads, there's not much you can do. That depends on our customer's system infrastructure. But if it's purely compute centric, we're seeing very large boosts in performance efficiency.
Amazing. And then so we've got a more performant GPU, a GPU that handles safety without compromising performance, one that is designed to handle the compute workloads of the future of automotive. For an automotive OEM looking to enable differentiated digital experiences in their car, what will this mean for them?
For the car maker, there's really a variety of benefits, right? We offer a lot of flexibility in our solutions. So whether the GPU is being used for graphical usage cases or for compute, it can really build on the flexibility in the functional safety, but also in the virtualization capabilities that we have. That also builds on top of our unique multi-core approach. So the multi-coring really allows us to adopt different models, whether we use a time-sliced virtualization or we enable isolation and freedom of interference. So a lot of the different car makers have the flexibility in how they want to approach the problems and integrate it into the core software choices that they are making. So we're offering them a lot of flexibility together with all the massive performance and efficiency improvements that we are making.
Thinking about how IMG DXS differentiates from the other cores on the market, how does it stand out? What is special about IMG DXS?
Our focus is always performance efficiency. So the key focus there allows us to deliver graphical performances in a fill rate centric case, which is very important for UI rendering, dashboards, the entertainment screens. And what we're seeing there in-house measurements is that we are up to twice as good as our IP competitor out there. In number crunching, gaming, graphics applications, we're also seeing a benefit of up to 28%, looking at really relevant usage cases in the automotive market. Now, all of that is without functional safety, because we're very unique in our approach to functional safety. Many other vendors don't even deliver solutions that can reach it. But there we can offer up to a 2x extra boost on top of all of this, simply from the fact that we have our ultra distributed safety mechanisms, which is really low cost and low overhead, as opposed to the traditional lockstep or run twice approaches. The last thing to mention there is the scalability. We are seeing a massive boost in graphics and processing requirements, and we can deliver a solution that is up to 4 times more performant than our nearest IP competitor for automotive functional safe solutions.
So, chiplets are an emerging trend that is set to be very important in the automotive market. How does Imagination support chiplets?
Indeed, chiplets are very important, really enabling customers to build different solutions from a single piece of silicon. And it's a very, very good match to our multi-core approach. So our multi-core is loosely coupled. It's not a centralized architecture. That means you haven't got all these wires going to a single central unit. Instead, our multi-coring has a very lightweight XPU bus within them, which is really register controls, event messages, and that really allows us to distribute our GPU cores across multiple chiplets and have a very latency tolerant, very lightweight bus that runs between the cores just to synchronize the workloads and the activities that we are doing on the GPU. So perfect fit, and there's lots of standardization efforts ongoing from our partners. So companies like Bosch and other are really driving chiplet standardization for the automotive market.
Thank you very much, Kristof. If anybody wants any more information on the Imagination DXS GPU, feel free to visit the Imagination website. There's also a very good white paper on the distributed functional safety solution that Kristof explained earlier. It's all available there. So thank you again. Enjoy your days.